As many as 10,000 coastal cities worldwide are at risk from rising sea levels. Joining us today is oceanographer and author John Englander, whose new book, Moving to Higher Ground, attempts to explain the long range implications of climate change on the built environment and what needs to be done in response to that threat. Welcome, John.
Hi, John. Thanks.
Uh, John, can we start off by getting a brief summary of the premise of your book?
Sure. It's that in the first case, we need to look at the facts about sea level and separate them from the other kinds of flooding that we tend to think about, like storms and heavy rainfall and runoff and coastal erosion and even king tides. Sea level is a special issue. And so we need to understand it separate from the other kinds of flooding and separate from sustainability and resiliency that we tend to think of and meld things together. The starting point is geologic history. Sea level moves up and down about 400 feet with the ice age cycles. Nobody doubts we've had ice ages. They may not know that they happen every 100,000 years, going back 2.5 million years, but that's well documented. And during those ice age changes, sea level just fluctuates on a 100,000 year cycle, as I said. As a result, 20,000 years ago, during the cold phase, the last cold phase, sea level was down 400 feet, 120 meters. It got to the present level about 6,000 years ago. That's pretty much recorded human history. We tend to think tomorrow is going to be like yesterday. So the first thing I do is to orient our tomorrows and yesterdays in terms of time length and help people out to realize that we're in a new era and we're breaking out of this point of stability, which was a natural cycle. And now we are in an extraordinary or unnatural cycle because we've warmed the planet, the ice is melting, the oceans are expanding. So the first thing is to put it in the context of geology. The second thing is to think about the effects on many of your sectors, John, architecture, engineering, real estate finance. And there's chapters in the second part of the book about that. Mm-hmm. And then the third part of the book is what do we do about it? And how do we get our heads into the psychologically, both the ethical issues, if you will, and the thoughts about what kind of world are we leaving behind, but also the psychological and political resistance to embracing this. And I'm not partisan about this, as you know from reading the book. We need to set the politics aside. After 6,000 years of stability, sea level is rising. It's going to be many feet higher, starting as soon as mid-century. We need to wake up and get ready.
And as you suggest in the book, the trigger to this phenomenon right now is primarily the CO2 level increase.
Yes, it was demonstrated in London in 1859 that carbon dioxide traps heat. It's a simple experiment you can do, and the CO2 level is now 40% higher. If people have heard of the levels, we're at about 415 parts per million. The normal range for the last millions of years was 180 to 280. Just using round figures. So it's way above the natural levels. And with higher CO2, we're going to get a warmer atmosphere. We've had warming and cooling before, like the ice ages, which is not caused by CO2. Mm-hmm. So we have to, and I explain all of that there's a natural cycle because of an orbital variation, but now we've superseded that. We've taken control basically by changing the atmosphere.
John, you talk about adapting to severe climate change and rising sea levels through resilience on a major scale. And that is going to include moving to higher ground in the coming decades. How do you convey that, though, to people who are skeptical of climate change, who are reluctant to believe that it's happening, or refuse to accept the need for that migration?
Well, as we've just been doing, I start with simple fact that can sort of correlate with things they know. We've had ice ages. They may or may not know that Cape Cod, Long Island, and the Great Lakes were all formed 11,000 years ago from the last ice sheet retreat, not that long ago in time. So when I give facts that they can corroborate somewhere else, that gives it credibility. I also separate the sea level from the other kinds of flooding that are easily confused, like hurricanes or even coastal erosion. So I give people grounding lines and points that make sense, that are constructs they can easily understand. I don't use technical language or jargon or lots of figures, as you can tell. And that tends to, I find, create trust and belief. And I don't even talk about politics. I've decided there's no place for that in this. I mean, if you care about your investments in your home and your community and where your kids live and your parents are buried or whatever, we should leave politics out of this and talk to people on a very human level, but an economic level, but even more important, and why I'm delighted to talk to your audience, a professional level, because it's the architects and engineers and also the financial community and the developers and the contractors that need to create a new built environment that anticipates or gets ahead of this curve of rising water.
Hmm. Um, can you identify some practical solutions? We're hearing all kinds of things out there right now about what cities are trying to do. Miami's trying to build a 20-foot wall that would keep seawaters out. Back on planet Earth, let's talk a little bit about reality here, and then what are some of the things you would suggest?
Well, the first thing is to look at the geology of the area, because as you mentioned, Miami, South Florida is porous limestone. So is the Bahamas, so is most of the islands in the Pacific and Indian Oceans, because they're built on ancient coral reefs. And that's porous rock. Even if you built a 20-foot high steel wall around one of those islands or the city of Miami, the water is just going to come up through the rock. So um, a big seawall in Miami does not keep out sea level rise. It'll keep out a storm surge and the waves that might come up the coast or up the river in Miami or Fort Lauderdale, but it's not going to keep out sea level rise. We need different kinds of solutions for different threats. And again, it starts with separating storms and storm surge, rain runoff, king tides, and sea level rise. And then there's erosion, coastal erosion. We need vocabulary, I'm just throwing it out there,
Hmm.
that allows us to talk about different problems, because different solutions will work for different problems. Now, in the next 10 or 20 years, sea level rise isn't going to be but a few inches higher. So again, we have to think of different time frames. I think you've referred in some of your work to 30 years with the normal building cycle. It's a mortgage cycle, right? And so 30 years is a great time frame. But buildings and infrastructure last 50 to 100 years very commonly. So again, we need to think with different time scales. A person's elected term in office may be 4 years, and maybe they're only planning to buy a condo or a house for 5 years, or they're doing a real estate development and going to flip it, in 6 or 7 years. So we tend to think short term. But the truth is, most of us use a house for 20 or 30 years. And certainly we finance it that long. We care about its value during that period. But beyond that, our kids and grandkids, get us to 60 years or 100 years. And that's the durability of the buildings and infrastructure. And we need a return on investment over that long haul. Because what's happening now is with increased flooding from these king tide events, people are starting to discount their values now and move to higher ground because they're tired of the routine flooding every 28 days at full moon.
Hmm.
And again, it's not a Florida problem. It goes from Galveston, Texas, around through Mobile and up to Savannah and Charleston and Annapolis and Baltimore and Boston and upward to Seattle and San Francisco Bay. And internationally, of course, from Copenhagen to Calcutta and from Bangladesh, to Burma, the coastal communities all over the world, the biggest port cities, Shanghai, for example,
Hmm.
or Hamburg, even an inland city. Flooding's happening all over the place. We've got to design better so that these structures, the engineering, architecture, and construction have durability. Otherwise, we're going to write things off prematurely. And if we write things off prematurely, the next round of financing is going to say, wait a minute, that building didn't last its design life. Why should I finance this one over 50 years for a bridge or a tunnel or something like that? Because
Hmm.
the financial community is going to get, attuned to it. I think I skipped one earlier question or didn't fully answer. You talked about resiliency and in effect sustainability, and how do we talk about it,
Well,
whether it's
that's
here in
that. That's
Florida.
what a lot of our viewers have already done in many of their projects. But it sounds like you're suggesting that they might just be at the tip of the iceberg here a little bit.
Great, pun, but very relevant,
Mhm.
that we are at the tip of the iceberg. And just like the iceberg only 10% above the surface, the bigger part is yet to come on this issue. And we need to separate and be more not distinct in our discussions and our engineering and our construction, because sustainability and dealing with climate change are actually too large a term. We need to divide them. For example, sustainability usually refers in the built environment today to being more energy efficient, to
Mhm.
maybe using, renewable energy and or energy efficiency. A high lead rating, for example, is very
Sure.
popular, which is great. Those things aren't going to stop sea level rise. We've already warmed the oceans. We could go to zero emissions today, and sea level is still going to rise for centuries. Okay, we've already
Mhm.
put that much heat in the ocean. So we have to separate sustainability, which to me is these issues like green energy sources, renewable energy, or recycling. That's sustainability. Resiliency is planning for events like big storms, wildfires, high heat days, heavy rainfall. Those require resiliency, but that starts this year. Sea level rise this year can't be a problem. It's only rising about a quarter of an inch a year, 5 millimeters. Sea level rise requires adaptation in advance to prepare for what we know is going to come 20 or 30 years from now. So sustainability, resiliency, and adaptation may all seem the same, but we need to be more intelligent and use more specific terms and realize that sustainability, resiliency, and adaptation are three different things.
Very interesting. John, moving to higher ground would relinquish billions, maybe trillions of real estate value. But your book suggests that new assets would be created by such a move. Can you elaborate on that a little bit for us?
Sure. Again, we think of flooding, we visualize a hurricane and a city going underwater, whether it be Katrina or Sandy or Harvey, any of these huge events. That's a lot of water in a day or two, right? Sea level rise is the opposite. It's this quarter of an inch a year, which will become a half inch a year, which will become an inch a year, and could become 10 feet in a century. Okay, a huge amount, but it's the drip filling the bucket.
Mhm.
We need to plan differently for that time horizon. And the reason I say that, even if we lose billions or trillions of dollars of assets to the sea, because it's relatively gradual, we're not that many people are going to die from it, fortunately. It's not like the tsunami that kills 200,000 people one night, or tens of thousands or hundreds and thousands in a hurricane. Sea level rise is going to displace hundreds of millions of homes, literally hundreds of millions this century. But fortunately, the deaths won't be proportional.
Mhm.
But you can't argue with a rising ocean. If we melted enough ice on Antarctica and Greenland to raise sea level this century 5 or 10 feet, 2 or 3 meters, which I think we will,
Mhm.
um, now is the time to plan in advance so that structures have durability and good return on investment. But the good news, as you suggested in your question, is even if we lose $1 trillion of coastal assets to the ocean rising, we are going to build that same value of assets because we have the same number of people or more
Mhm.
people.
Mhm.
And so, for whatever value we lose to a rising sea, we will create that value or better. And interestingly, the engineers and architects and builders and those financing those structures have an opportunity to show that they've invested in the future and that their projects have durability and a better return on investment, which enhances their value. Because right now, the opposite's happening. People are seeing more and more flooding during king tide days, and
Yep.
they don't want to pay the asking price for assets because they see the water showing up, or even if it's not at their property, it may be the house below them. And properties are being discounted. There's already like a 15% discount on comparable properties where they're vulnerable to flooding.
Mm.
That's going to get worse. So it's an opportunity to turn around and say, let's design for the future. And it's not just sustainability and not just resiliency. We're going to be adapting in advance to something which is now, in the pipeline.
Mm. John, lastly, what's your best and worst case scenarios as it pertains to rising sea levels over the next 30 years? And how sanguine are you about the industry responding to all of this?
Um, Great question. So at the moment, as I said, sea level as a global average is rising about 5 or 6 millimeters a year. That's about a quarter of an inch. Small stuff, but it's cumulative, like the drip filling the bucket. This decade, maybe an inch or two, or three, okay, something like that. But 30 years, mid-century, we could have maybe 6 inches as a best case, maybe four times that as a worst case, 2 feet. So in metric, that's 15 centimeters, sorry, to 60 centimeters, almost a half meter.
Mhm.
But it's going to accelerate, and it's going to be clear that it is accelerating. And just as we learned with the pandemic, it's not just what the models show and that they're all over the place, but how quickly they can turn and change from linear growth to geometric growth to exponential growth and catch us by surprise.
Right.
And that's the same problem here. We're going from these small amounts of a couple of millimeters or fractions of an inch, but it's very easy to get to 5 or 10 feet a century. That happened 11,000 years ago. 11,000 years ago, sea level rose 65 feet, 20 meters in 400 years.
Mhm.
A staggering amount. That was without human impact. That was a natural cycle. Now we're in a different situation, but we can learn from the past.
Mhm. John, thanks for taking the time to speak with us about this. This is really a fascinating subject and one that's going to affect a lot of people in our industry and elsewise.
Well, thank you, John. I really appreciate it because, as you say, it is your industry that's going to design, engineer, build, and finance, the structures, the infrastructure, and the communities that will adapt to rising sea level.
Mhm. And thanks to our audience for watching. This is John Caulfield from Building Design and Construction.